Did you want to?
Oh, yeah, good evening. Welcome to our next installment of the Boston College Data Science Speaker Series. My name is Emma Klugman. I'm a professor of the practice in data science here, and I direct the MS in Data Science program and love coordinating community events across all of BC, not just for the MS program, but for undergrads, grads, faculty, and staff. And the speaker series is a great place to bring people together. And we get to hear from amazing speakers in all kinds of different fields and areas. So we're very excited to welcome you all tonight to a talk from our speaker, Emily Yu. Emily is a data scientist in the customer experience team at Microsoft, where she builds comprehensive data solutions to help customers maximize value from commercial cloud products. She creates integrated data pipelines for finance and sales teams, develops AI-powered conversational interfaces for complex datasets, and analyzes user behavior to continuously improve AI-driven business tools. Tonight's talk will be recorded, and we'll be sharing out that recording later. The rough agenda is that Emily's talk will go for about sort of 40 to 50 minutes, and then we'll have time for a Q&A afterwards. If there's any kind of tech issues or logistical questions along the way, feel free to send those through to me in the chat, and we'll see what we can deal with on the fly. But otherwise, uh, delighted to have Emily join us. Thank you so much for being here tonight. Let's hand it over to our speaker, Emily.
Yeah, thank you, Emma, for that wonderful intro. Hello, everyone. So great to be here today. Thanks for the opportunity to be here and share my work with you all. As Emma said, I'm Emily. I'm a data scientist at Microsoft. And I'm here to talk about how data science and AI help us understand cloud consumption at scale at Microsoft and how that enables smarter decisions across teams like finance, sales, and engineering at a big enterprise like this. Um, but before we dive in, I wanted to give you a little bit of a, glimpse into how my personal journey went to, getting to data science. I actually didn't start out in data science. My background was in civil engineering. So I really thought I'd be designing roads and traffic systems for the rest of my life. Anyone else come here from a non-data science background? Do you want to, if you want to just type it in the chat, would love to see the range of experiences in the room as well. I need to figure out how to open the chat window from this. There we go. Okay. Environmental science, Mechie, education, econ. Okay, I love seeing the various backgrounds here. Great. Yeah. Well, what ended up drawing me to data science wasn't really in concrete or bridges, but it was actually the math behind it. I love taking courses like numerical methods and modeling. And then I realized that those analytical skills could be used in an entirely different way in, working with data to solve real world problems, especially in tech. So that led me to pursue a master's degree in operations research and analytics, which eventually brought me to Microsoft. Now I'm part of the customer experience data science team. So we're focused on driving Microsoft's AI transformation. We are a little special in that we're a centralized team of data scientists only. So we use analytics, apply machine learning, and AI to help our customers be more successful with our products. We build production-grade ML and LLM models. We create scalable frameworks for model development and deployment. And we also lead evaluation efforts in AI, where we quantify business impact and we track progress with standardized metrics across the organization. So we're really at the intersection of data, engineering, and business, helping Microsoft make sense of how customers use our products and where we can do better. Um, and yeah, when I was pursuing my master's degree, I've always wondered what it's actually like to be a data scientist. So today I'm hoping to give you a glimpse into that world and what our day-to-day work actually looks like. So let's shift gears a little bit and talk about something at the core of our cloud business, which is consumption. There we go. Um, So in the world of Azure and cloud services, consumption, it really is everything. It's how we understand what our customers are actually using. And that usage is what drives our revenue, our growth, and decision making. To break it down, there are two key terms that we use a lot. So first is what's called ACR, which stands for Azure Consumed Revenue. And this is an internal metric that tells us the economic value of Azure services that are actually used. So it helps us track cloud adoption, understand customer usage patterns, and measure the health of our business overall. On the other hand, we have this thing called billing revenue, which is what the customers actually charged. So this happens at the time of billing, and because of that, it can lag a little bit behind ACR. And it also includes things like things that aren't really tied to direct usage. So things like support plans or one-time fees. Those are all included in the billing revenue as well. So the way you can think of this is consumption is actually a product of price and quantity. So for example, let's say you're running an A series virtual machine, which is price per hour. So the more hours you run the virtual machine, like obviously the more you're consuming, so your consumption will go up. But revenue, on the other hand, is a little bit more nuanced in that it's calculated by doing consumption minus concessions, whereas where the concessions consist of discounts, credits, and any other like special deals that we've offered to the customer. And these metrics aren't just, something that lives in the spreadsheet somewhere. These are some of the things that like directly influence um, other things like how Microsoft reports earnings and forecast growth, how we price Azure products versus our competitors like AWS and Google Cloud. And it also affects how we structure our contracts and deals for large customers. So to give you a more of a concrete example, let's imagine that there is a big, large enterprise customer whose Azure contract is coming up for renewal soon. And they're committed to a multi-million dollar agreement. And now we need to figure out things like how much did they actually use, what discounts we've already given to them, and what kind of offer makes sense for a renewal for this customer. And figuring these out, it's not super simple because every program has its own rules and definitions. And that's where we as data scientists, we come in and we help these teams across Microsoft answer tough questions with the right data at the right time. So let's talk about one of the biggest challenges in understanding cloud consumption, which is the complexity behind the Azure pricing landscape. So now, like at a first glance, you might think that pricing is pretty straightforward. A customer uses a service and we charge them for it, deal done. But in reality, it's much more intricate than that. So for starters, there isn't just one way to price our services. So there are like multiple pricing and discounting programs, each with its own logic, rules, and tracking systems. So here are just some of the examples of the many programs that we have. We have something called MAC, which is Microsoft Azure Consumption Commitment. And I'm just listing these out right here because I'm going to give examples of like different projects that I've worked on. And they're all going to like involve these terms so you can understand those better in a couple minutes. So MAC deals are like cloud contracts. Customers commit to spending a certain amount over a set period of time, and they get discounts in exchange for that, basically. And then we also have these programs called reserve instances and savings plans, which let customers lock in the resources ahead of time, usually 1 or 3 years. And then in return, they get guaranteed capacity and substantial discounts on top of that. And we give discounts for these because then we can basically like allocate the right resources better. And we also have something called credits. These are like free cloud money we give to the customer. So we might give them out to, let's say, apologize for a downtime. Surprise, AW was having their outage today, so it's a perfect time to, mention something like this, and to incentivize a customer for trying something new as well. And lastly, we also have negotiated discounts, And these are custom agreements where we might offer a specific percentage-based discounts on certain services for the customer. So already we're managing multiple overlapping programs with different terms, timelines, and pricing rules. But that's not all of it. So it gets even trickier than that, actually. I remember this formula from just a couple slides ago. Consumption is equal to price times quantity. And both of these variables are deeply complicated. So for price, it can depend on the customer's region, so like their geographic region, their specific discount agreements, their service tier, and the duration of the commitment, and a bunch of other things. Quantity isn't super uniform either. So every Azure service measures usage differently. We might have something that's measured in hours, gigabytes, transactions, and something else entirely. And with hundreds of services and deeply nested service hierarchies, standardizing this is a pretty challenging thing to do. And then we also add in customer variability. So Microsoft, as you probably know, serves everyone from individual small developers to global enterprises. Some customers have dozens of subsidiaries, each with their own billing accounts. Others have geographies with different tax structures. And one customer might be split across multiple tenants, making it hard to even answer a super basic question like, what exactly do we mean by a customer here? And their needs really vary too. So we have large legacy enterprises, which often lean on IaaS or infrastructure as a service solutions. They tend to get super high discounts because their workloads are very, very easy to move. And our competitors are also chasing after them. On the other hand, we have smaller customers who they might not have the budget or the stability to make big upfront payments or commitments. So instead of offering them a lot of discounts, we actually end up offering them more flexibility with their services. And for startups, we have a startup program where we support them with cloud credits that they could use across Azure, including our AI products, so that they can get off the ground super fast. And then all of this happens at scale. So we're talking about millions of usage records per day. So when you hear like cloud pricing, we're not talking about simple price tags. Think of a constantly shifting puzzle with 1,000 moving pieces, all tied to different customer needs, business strategies, and economic signals. All right, well, so now that we've seen how complex this entire problem can be, let's talk about who actually uses this data and why this matters at our company. So first up, we have a finance team. And these teams rely heavily on accurate consumption data to first report revenue and usage trends. So they need this data to identify any market trends so that impact business performance. They use this to validate the discounts and to validate that the discounts and the promotions that we're giving them are applied correctly. Are we like honoring the contract? Are we over discounting? And you'd be surprised to see that actually this happens quite often where we think we're giving them X amount of discounts, but we are actually giving them Y amount. And they also use it to forecast future revenue and explain any sudden dips or spikes in the numbers. And they use all of this to tailor deal structures. So making sure that what we offer customers actually makes sense for the usage patterns. Then we have our field and sales teams. And these are the ones that are working directly with the customers. So they use this consumption and pricing data to build account plans for larger and strategic deals. And this a data set like this could help them close the deals a lot faster with better win rates and align with their broader Azure goals overall. They also create action plans if a customer usage isn't like meeting the expectations that we have for them. And they also run competitive scenarios. So if we want to win a customer from another cloud provider like Google, let's say, we need accurate pricing models to show how we're stacking up compared to them. So these are some of the scenarios, business scenarios that the sales team would use such data. And then behind the scenes, engineering and data science teams like mine are the ones that are building the data pipelines, models, and tools to power all of this. We ensure that the right data gets to the right people in the right format so that they can make decisions more confidently and quickly. Um, and all of this becomes like very real in scenarios like, let's say a finance person spots a sudden revenue dip in one region, and they'll come to our tool and wonder like, what exactly happened here? So then that leads to a full investigation of did a big customer reduce consumption, or did we end up like applying too many credits in this region? So to answer questions like this, we need pricing data, usage patterns, and deep knowledge of how our discount programs work. So it's truly like a group project, honestly. Sales is the one presenting it to the teacher, aka the customer, but it only works if everyone's done their part behind the scenes. And just like any other group project, it can get pretty chaotic if we're not in sync about all the definitions. So understanding cloud consumption isn't just a technical challenge, but it's foundational to enterprises like Microsoft, how we make business decisions across teams, basically. So enough about the business. Now we'll talk about data science. Um, now that we've seen just how complex and important cloud pricing is, let's talk about where data science makes a difference. And this is where we move from understanding the problem to actually solving it. So let's start with a couple examples of modeling and analysis, where we apply data science techniques to help these businesses make smarter pricing decisions. Um, so remember how we talked about MAC deals where the customer would basically like commit to a certain amount first upfront. So with those deals, one of the common questions is, was this deal really worth it for us from the company's perspective? So in this project, we built a Power BI-based visualization tool that analyzes customer behavior before and after signing the deal, or at renewing or signing the deal. So it tracks metrics like revenue growth trends, consumption patterns across different service categories, and changes in consumption types. So we could have seen one customer go from a lot of like negotiated discounts to a lot of like reserve instance discounts instead. So by decomposing revenue into its underlying drivers, we can see that the deals team would have better visibility into how the customer's cost structure is evolving over time. And this helps answer questions like, was the discount structure effective? Should we offer a similar deal to a similar customer segment? And did this customer underperform after the contract, which like does happen like once in a while too. So um, yeah, uncovering insights like this could be possible by having dashboards and insights from the dashboard. We also work on some like more analysis-based projects as well. So this one involved understanding how reserved instance or RI adoption impacts customer growth and retention. Um, RIs, basically, they offer customers discounted rates in exchange for longer term commitments. So this sounds like a clear win for both the customer and us. But the actual business effect depends on who adopts them, how much of their overall portfolio they commit to, and whether that commitment promotes stickiness or stalls future growth. So to unpack stuff like this, we use a combination of regression modeling and classical machine learning techniques to evaluate both the short-term and the long-term effects of RI usage. So like the basic workflow for this goes from customer segmentation. So we focused on customers with substantial ACR or Azure consumed revenue to ensure that there's material impact because these are typically large enterprises or growing mid-sized customers whose behavior meaningfully affects our forecasts and revenue planning. So we basically take out the customer segment that we want to look at. And then we go into some exploratory data analysis where we found that customers with absolutely zero RI utilization, they tend to behave very differently from the ones who actually do use it. So for cleaner signal, we filter to account with at least a little bit of RI adoption, which allowed us to compare partial versus deeper adoption levels a lot more reliably that way. And for modeling itself, we use regression and classical machine learning models, probably some of the ones you've heard of already, random forest, gradient boosting, and such, to estimate the projected ACR growth based on the different optimization levels. So we're looking at customers who have like 10% RI coverage versus 50% RI coverage, and where is their ACR projected to go in the future. And then for the forecasting scenarios, based on the models, we created a forward-looking simulation that shows how a customer's projected ACR might evolve under different optimization scenarios. So these forecasts supported our sales and finance teams in structuring the deals, helping answer questions like if we recommend the customer a 30% RI optimization today, what will they spend like, what will their spend look like 6 months from now and 18 months from now? Does that really lock them in, or does that free them up to, grow even more later? So these are some of the questions that we're trying to answer by running some classical machine learning models. This one is interesting. It's not very typical of what we do every day, but this is an interesting question because we have this another program called ESIF and Customer Investment Fund. This is where we provide financial support to customers to help them migrate or deploy Microsoft solutions. And the process goes from it involves multiple stages. So it goes from request to review, approval, and then payout. But the cycle time or the time between the request creation and the closure of the request actually can be pretty long and variable across the different customers. So our goal was to better understand how long these ISIF approvals take. And we had just made some AI-driven process changes to the entire system. So we wanted to understand if that made any difference in helping the sellers get them approved a lot faster. So to do this, we used something called Kaplan-Meier survival estimator. This is a statistical method that's designed for analyzing time to event data. So, and this is especially useful if some of the events haven't really occurred yet. So we call this sensor data. And in our case, the event is the ESIF approval, and sensor cases are the ones that are still in progress. So we're not able to observe them just yet. And a method like this really helps us estimate the probability that an ESIF request remains open beyond a certain number of days. And it gives us a much more accurate view of approval cycle time, because if we were to, let's say, just use very simple averages, that would like undercount the long running requests just because we don't get to observe them. So by tracking changes in the survival count over time, we could directly measure whether improvements, like new copilots or automation of data sets, were reducing the number of days it would take to get these approved. And this became a key metric to evaluating, operational impact and where additional optimization was needed. So this was an interesting project. It was fun to work on. All right, well, we talked about modeling and analysis so far, but modeling is just one piece of our work. A big part of another big part of our job is actually making this data accessible, reliable, and usable. And that starts with pulling together fragmented data. And so you'd be surprised, but data is very scattered across the company. So you would need to basically gather everything up from many different sources in different formats and different, storages. So we have data living in Cosmos DB, Azure Data Lakehouse, Lake Storage, Kusto, and a bunch of other ones. And each source has its own schema, latency, and like little quirks. So you have to first gather those up, And then you sit down with the stakeholders to define the metrics that actually make sense for your use case. So in creating this pricing and Azure consumption data set, we have to ask questions like, what exactly counts as a discount? Like, what do you mean by a discount? And should we calculate against the list price or the price that's, listed on our website, or do we calculate it against the negotiated contract price? Um, and then after that, to handle the scale of our data, and to do data transformations, we use Spark. Um, I don't know if anyone's used Spark before, but imagine trying to process billions of rows of data or join multiple huge tables on your laptop. It would just take forever or it'll just crash on you. So Spark solves this by splitting the job into multiple smaller chunks and then spreading the work across multiple machines called workers. Um, and each worker handles a piece of data in parallel, and once the work is done, Spark brings the results back together and writes the result to efficient formats like Parquet or Delta so that it could help speed up the analysis later on as well. So yeah, that's what makes Spark really fast and scalable, and that's why we use it for building the pipeline and transforming the data. So once we bring all the data, we build production-ready pipelines off of that. So that means we're moving from, oh, I ran this analysis in a notebook format to a fully versioned, monitored, and deployable system that everyone else at the company can use. So we did this in tools like Azure Synapse, Azure Machine Learning. We added CI/CD, version control in Git, and robust monitoring to make sure that these pipelines, if they do end up failing in any way, then we are aware of them so they don't just silently fail. And lastly, on top of that, we design front-end tools that make all of this really useful for the real users. So just a quick show of hands, I want to ask, has anyone used visualization tools like Power BI, Tableau, or any other similar visualization tools? How do I see? I'm struggling with Zoom right now. Okay, I see Emma, your hand up. Power BI, yes. Perfect. Yeah. So as you, I don't know what your opinions are on visualization tools like this, but a lot of personas in finance and field prefer these kind of, visualization tools over actually like going into SQL or Spark themselves, that they actually like prefer that. So that's why we have to go in and create things like data cubes, Power BI dashboards, Excel tables, and any other tailored UIs for these professionals. And so more increasingly that they are asking for things like Copilot endpoints where they can just go in and ask the chatbot for the numbers that they want. So yeah, one quick real example of this is that one of the field workers, he had this 30-minute manual Excel workflow that had to be done for every customer that he owned. But with the creation of this data pipeline and the dashboard that shows the data from the pipeline, we could just refresh the dashboard and then it just could be like updated in seconds. So we save so much time just by creating this product. And of course, it's not all smooth sailing. There are challenges too. Uh, I chose this picture because they all look pretty serious. That's what we look like in meetings too. Um, but when we're working on products like this, we see that data is basically like siloed and it's very scattered across the company. So that's a big challenge. We're constantly adapting to shifting business definitions. So every single fiscal year, there's also always something that changes in the data. So we have to go back and, like reapply some of the new business logic that's defined now. Um, and we're tuning performance at serious scale. There are joins across billions of records of usage and revenue data, which isn't really simple. You have to choose the right types of partitioning strategy, join types, and even like choosing the right cluster size can really make or break a pipeline. But yeah, that's all these challenges are the ones that, makes this work fun and impactful. And all of this from the models to tools is what turns complex pricing into actionable insight. So now with AI, we're taking this even further, actually. How is AI changing the space? I feel like AI is such a buzzword these days. This is what everyone's talking about. And, it is true that AI is truly transforming the way we work. We're moving from static dashboards to real-time intelligent assistants. And these AI-powered tools are really changing the game. I want to say they mainly come in two flavors. So we have copilots and agents. While both are driven by AI, they really serve different purposes in streamlining your workflows. So, what exactly is the difference? So, think of copilots as your intelligent collaborator. They sort of sit beside you, they offer insights, summarize data, help you reason through choices, all in real time. They make you more effective at your job by enhancing the decisions that you make ultimately. Agents, on the other hand, they're more autonomous. They don't just help, but they actually do the work. So they can carry out tasks or entire workflows on their own with very minimal human intervention. Uh, and the beauty of this new AI era is that there's really space for both. So we have copilots that enhance human capability and agents that extend it. So here's a great example of how an AI agent can work in practice. So we have this thing called sales order agent, which it was in public preview a couple months ago. It might be a GA now, but it automatically monitors a mailbox for incoming sales requests for sellers. And if it spots anything that's unusual, like a special customer instruction or an incomplete form, then it doesn't just fail, but it actually flags the issue and drafts a message for the sales team to review. And then it can even create sales quotes, update the deal details, and then push that information to the CRM or a customer relationship management system automatically. So it really saves a lot of time for the sellers. So it just means that sellers don't have to spend hours managing their inboxes and looking for missing information, entering the data, but instead they can focus on the more complex and human parts of their work. So the relationships they're building with their customers, the strategy, and the deals that actually move the business forward. And that's what agents are great at, automation with intelligence, really like freeing up human time for more creativity. Um, and shifting to co-pilots, they are like real-time partners in decision making. So we have a co-pilot that's for sellers. Um, Today, a lot of sellers rely on fragmented reports, CRMs, and manual analysis to plan milestones and forecast Azure consumption. And they might have to pull this data from like five different, places and try to piece it all together to answer really basic questions like what's the forecast for this quarter? How are we tracking against our MAC commitments and such? And this is really time consuming, in addition to being prone to human error in the process. So this AI-based tool we've been building changes that completely for sellers. Instead of navigating through reports, you can just ask the question in natural language. And behind the scenes, the Copilot translates that question into SQL queries, runs them securely against the data model, and then returns the answer for the user that's clearly formatted and contextualized so that they can take action on it right away. So now that we have an idea of what these are, we can talk about what we do in creating these. So of course, making something like this work isn't just about the AI model itself. It's a deeply collaborative effort across engineering, data science, and product teams. So from the data science side, though, we have a couple of key contributions. First is prompt engineering. So we design and refine the prompts so that the model can really accurately translate natural language into structural SQL queries. And then we also work on things like data model design. So we shortlist key metrics and dimensions for the SQL queries, and we define the logic so that the queries can be routed to the right tables. There's also evaluation and testing, which is really important. So we develop benchmark data sets, test prompt variations, and validate SQL outputs for accuracy so that they actually match what the users expect. And then lastly, we have quality assurance. So running semantic tests, going through user reviews to make sure that every answer is not just technically correct, but also contextually meaningful. Because the LLMs are honestly only as good as how much context and like input you're providing into it. To give you a general understanding of the high level architecture of how this works, we have the client layer where the user asks natural language questions via like a Teams app or CRM tool. So they would ask questions like, what's the ACR for this customer XYZ and their year-over-year variance? Like, what does that look like? Then that question would get directed to the orchestrator layer that classifies the intent of the question, and then that would route the question to the correct plugin. The plugin layer then translates the natural language into SQL queries and then applies domain mappings and formats the results for conversational output. Then it goes on to the data layer, which connects securely to the underlying SQL sources that are put together. And then with scope access so that users can only see what they're authorized to see. On the side, we have telemetry and dashboards that for monitoring latency, routing accuracy, response quality, so that we have a good idea of where we need to improve. And all of this together creates a seamless loop between the user's question and the data insight. Here are some of the key things that are really, really important to make sure that the AI agent, copilot, whatever you're creating is working really effectively, because having strong foundations is key. Like first thing is data quality and governance, because poor data quality leads directly to hallucinations. Governance really ensures reliability, and having consistent validated data is critical for accurate answers, because if you just have garbage, if you just feed the model garbage, then it's only going to spit out garbage. Metadata also plays a big role in AI systems to understand context. So having clean, well-structured metadata helps agents make sense of complex data sets. For clear logic, co-pilots and agents, they don't just process data, but oftentimes they make decisions. So defining this logic behind these decisions ensures that they behave predictably and appropriately to answer the right questions and perform the task correctly to like whatever they're assigned. Security and access controls is also a big key. AI systems need the right data, but they don't necessarily need all the data. Granular permissions ensure that your AI tool respect data boundaries. So for our example, making sure that pricing logic is kept internal and respecting who can see what kind of data, because not everyone has access to all types of data. And of course, everything must align with enterprise grade security overall. And finally, we have feedback loops in place because AI systems should learn from how users interact with them. So capturing feedback, whether it's like thumbs up in an app or follow-up correction directly from the user, these kind of things help the model continuously improve and adapt to new use cases over time. Okay, so now that we have these co-pilots and agents that are live, how do we know if they're successful? How do we measure their success? And this is another part where we as data scientists come in and play a big role. So when it comes to measuring AI's impact, there isn't one single metric that captures the full picture. So I like to think of it as, a connection of 5 different dimensions. So we have usage and engagement, performance, response quality, sentiment, and business impact. The usage and engagement is what a lot of people like mostly think of when we say metrics, it's often the first signal we see. It answers questions like, are people actually using this tool and how are they using this tool? And so here we track things like number of active users, prompts per week, adoption rates, retention. Are the users coming back basically? But the thing is, like raw engagement doesn't necessarily mean impact. You got to have sustained engagement paired up with meaningful use cases to tell us whether AI has become like a big part of somebody's workflow, not just something that they try really quick and they just leave. Next comes model performance, the reliability and efficiency of the system itself. So this dimension answers questions like, is the AI actually working well? So we look at things like latency, basically like how fast the responses are generated, uptime and stability of the system, error rates, reliability. So having strong technical performance ensures that any downstream measurements like satisfaction or business impact, they're not hindered by any kind of friction by the user. Response quality, even with strong performance, the quality determines whether AI outputs are actually useful. So we can measure things like accuracy and relevance, coherence, groundedness. A lot of AI tools like AI evaluators have like other metrics like blue glue, things like that to, like help us understand the quality of the actual responses themselves. So high quality responses increase user trust and promote sustained engagement, which is a key sign that these models are actually adding real value, not noise. Sentiment is also a big piece because it tells us how people feel about AI in their workflow. So we get qualitative feedback directly from the users, just quotes verbatims. We also look at behavioral sentiment. So how looking at things like how often users escalate for help and other more quantitative things like number of thumbs up or down that we get from users, how many times the LLM like apologizes to the user saying, oh, sorry, we can't answer that question. So these kind of data, sentiment data, helps diagnose friction early on, signaling a need to improve, you know, clarity or trust in our system at times. And lastly is the business impact, um, which is basically, does AI create tangible business value? And this can take many forms, such as time saved, so efficiency gains, faster insights to action cycles, and revenue influence, so uncovering any opportunities for or accelerating deal closures. Um, and these metrics often take a little bit longer to quantify, but they do represent the strongest proof that AI isn't just something that's interesting for us, but it's actually transformational in our day-to-day workflow. So when tracked together, all these layers create a holistic view of AI success, not just as a technical innovation, but as really something that enables our organization to work better. So before we wrap up, just wanted to leave you with a couple of key takeaways, whether you're just starting your data science journey or whether you're looking to grow in the field. One is that data science is like a team sport. So much of what we do isn't just writing code or we're not just building models. We're really collaborating across engineering, finance, sales, and business teams. And some of the most valuable skills you can build are around communication. So translating the technical insights into business impact, asking the right questions to clarify what your stakeholder actually needs. Second is the boring work matters. You know, things like data cleaning, aligning definitions, maintaining pipelines, like these don't are not the things that sound the sexiest, to be honest. But they're what make great models possible. And in fact, most of our biggest wins have come not from just fancy algorithms, but from getting the foundational data right and building scalable systems around it. Third is stay flexible and keep learning. The tools that we're using are constantly evolving. 10, 20 years ago, I don't think Spark was like the standard. Just a couple of years ago, nobody was talking about copilots. No one was building copilot endpoints. And now it's a core part of our everyday work. So stay open, experiment with new techniques, and don't be afraid to step outside of your comfort zone. And finally, don't underestimate the power of storytelling because being able to frame your work in a way that others can understand and get excited about is what really brings it to life. So whether it's a dashboard, like a slide, conversation, how you tell the story of the data is just as important as the numbers themselves. So yeah, those are just some of the points that I wanted to leave you with today. Thank you so much for spending time with me. Whether you're debugging a pipeline or shaping pricing strategy, just remember that data science isn't just about the data. It's about driving better decisions, building the trust for your data, and creating impact at scale. So yeah, I'll be happy to take any questions, or if you have any comments as well, I'd love to hear them.
So I have a question.
Sure.
Let's see if I can frame it right. So you talked about kind of the different dimensions for measuring like what is it, the impact of like the AI co-pilots and agents, I think.
Mm-hmm.
And so for response quality, is that something do you get like some sort of like information from the actual user, like they, rate this response great, and then, that tells you if it's an accurate response or not? And like, how do you deal with people or like the data when people are not necessarily rating them? Or is that something that you encourage for them to actually rate it so that way you know that the response quality is good?
Yeah, thanks for that question. So you're talking about two different circles here, actually. So for response quality, we're looking at the quality that the AI model has generated itself. So for things like that, we do keep track of the user questions, so what they're asking, in addition to what the AI model is spitting out to them, so that we can sort of do like match them up basically. There are other like frameworks that you can use within Azure AI Foundry that we can use to you know, evaluate how like relevant the responses are to the question, how like coherent the response is, how like how coherent is it, how fluent is it? Whether it's like grounded in the right context that it has pulled. So things like that is what falls under the response quality bucket. For in terms of how the user rates the answers that they're getting, that falls into the sentiment bucket. So for those ones, we do encourage the users to submit any feedback. We have like this little thing on the side that just tells the users to, give a thumbs up if you like the answer, thumbs down if it didn't work. But obviously, those are a little bit biased in that the user is only going to give feedback if they're either really, really satisfied with it or if they're just like really unhappy about it. And we've noticed that we've been getting a lot more downvotes than upvotes because, most people who submit feedback, they're not happy. So that's why there's so many feedback. Um, so in fact, we've actually developed another like machine learning based model that sort of predicts whether the user feedback would be positive or negative based on the responses and the questions themselves. So those are just some of the ways we're trying to like guesstimate what those feedback would be like because the feedback data is obviously not the volume of the feedback data is the issue here. Any other questions, thoughts, comments?
Hi, Emily. Yeah, thank you.
Oh,
And first, thank you for your presentation. And I have a question about um the one you mentioned before about the copilot and intelligence agents. So I'm just curious, like how like do data science like decide like what level of autonomy like is like appropriate for an agent to have like how much of autonomy would you like give to the agent like to have for them for the customer, especially when you like kind of like balancing like the automation and like homer like human oversight.
do you mean when we're building these agents, how much autonomy we give to the agent? Is that what you're talking
Yeah,
about?
yeah. Like when you're doing the transition from Copilot to the intelligent agent.
That's a good question. So it really depends. We would have to look at the autonomy and complexity. So, if the task that you're trying to get done, uh, involves if human judgment is critical in what you're doing, then you would obviously want it to be more like a co-pilot because you would, need that you would need human intervention there. But if the task is well defined and rule based, if it's like very something that could be like automated almost, then an agent would be more suitable. So in this use case, like for the sales order agent, writing emails that are based off some of the forms that are already like filled out, that is something that could be easily automated, right? So stuff like that an agent can take. But when it comes to actually like maybe like for specific special deals that the customer if a customer has like something more like a special case that the human needs to like go in and take a look at, then the the flagging of that could be done by the agent, but the human needs to actually go in and like, you know, deal with that special scenario. So I'd say it's like a balance of autonomy and complexity. Um, you need to consider also the impact of the errors. So because agents need like robust validation to avoid any cascading mistakes on the downstream of things. So yeah, like for example, like in this case, just writing that email, a human can review it at the end. Once an agent has generated the email, the human can just go in and review it. So that would be something that would be ideal to have an agent in versus a co-pilot would basically be like your driver, like literally like your pilot, like alongside you, where you still need to get the work done, but it'll just be like an assistant for you, if that makes sense.
Yeah, that makes sense. Thank you.
Thanks for your question. There's a question in the chat, Chen Hao. Wondering in these situations, how do you or your team actually evaluate the work, whether it's successful or not, or how effective the method is? Chen Hao, can you elaborate on what kind of project or what kind of situation you're referring to?
Yes, sure. I was just wondering, since you have shared so many real world examples of how data science could help the team, and I'm just wondering how internally would you or your team look at the solutions or comments provided to other coworkers, and how would you actually evaluate whether this is true or this is not true, or how effective this is helping other teams to do their jobs? Like, is there any check that you would do or evaluate on the results before sending it to other coworkers?
Mm. That's a good question. You're talking about how our promotion things work, our performance guide works. No, but for it really depends on the context and the type of project that you're working on. So it is true that for, let's say, certain analysis projects, you would need to sort of honestly like chase after your stakeholders and basically like get feedback, either qualitative or quantitative, from them to understand like the actual impact that your work has made. So for example, building that data pipeline and we like that data pipeline saving a seller 30 minutes per customer, like that's something quantitative that we can, measure. So we can say, hey, like this pipeline that I built has saved like this many hours per seller per year. So you can basically keep track of that. Uh, for something like um, there are other machine learning models that the team has built that, for example, something that generates recommendations for sellers to help them figure out what next actions and next steps they would need to take. For something like that, we could measure the the I don't want to say revenue, but the basically the dollar amount that model has helped create down the line, because sellers have this entire process of like they have to be basically keep track of the actions that they take, and how many dollars that has led to. So you can keep track of how many dollar revenues your machine learning model has led to, basically. Like, even though it's somewhat indirect in that it has influenced the seller to take that action, which has generated the dollar values. So those are some of the metrics that we try to keep um, to evaluate how successful or how well the each project has worked. Obviously, it's not that easy for certain kind of projects. You know, if it's like the first example, the visualization project that I was talking about, that one doesn't directly translate into like a dollar revenue number. So because it helped the deals team better understand the deal structures that they already had so that they can help the customer. So in those sense, like you would just need to ask your stakeholders or coworkers for like more like a qualitative review of how your work has impacted their workflows. So it really depends on the context and the project itself.
I see. Thank you so much, especially about the machine learning part. I was actually wondering how, because machine learning is sort of a black box, and I was wondering how you could be certain about the results of the machine learning. But thanks for answering.
Yeah, I'd say I feel like in academic setting, oftentimes we look at like a machine learning model and we care about like the accuracy, precision, like whatever those kind of metrics of the model itself. Whereas in practice, like people, yeah, people care about that. People will ask you about those kind of metrics, but what really matters is the business value that you create from those models.
Got it. Thanks.
I think we have time for one more question from folks if there's one more question.
Hi, Emily. Thank you so much for the talk. So you mentioned that data science supports decision making across finance and sales. So I was wondering, like, what skills area or knowledge areas do you think are most important to work effectively in that intersection? Like,
At the intersection of data science, so like as a data scientist working with
yeah.
sales.
Mm-hmm.
Yeah, that's a great question. So, I think I've tried to sort of emphasize it throughout the entire presentation, but when it comes to working with sellers, marketing people, finance, you have to understand that they don't speak your lingo. Oh, they have very different background from you, so oftentimes I've noticed that, sometimes like I would want to use like a very fancy ML algorithm that could give you like the best accuracy possible. But oftentimes that just doesn't really land well with certain stakeholders just because they don't know what you're talking about. So you might have to just like take a step back and figure out like how can I best translate what I'm doing to the stakeholder so that they are able to understand and accept your solution, because like convincing them you that what you did is valid and it makes sense and it will benefit them in the long run is like also a big part of the job. So I'd say communication skills is definitely key. Second thing, this is something that I initially struggled with a little bit when I first started out, is that you have to really think about things from their perspective. You have to put yourself in their shoes. So think about like, what would they want to do with this data? What would they be looking for? How can I make their lives better? Because I think it's like very easy to just get bogged down into details of like, oh, how can I like join these two data sets better so that my pipeline can run like 10 seconds faster, which is like important too. But again, your end goal is to make sure that the product or service or whatever you're building satisfies the user's needs. So you have to understand what the user wants and what kind of language they're speaking. Because like there have been a lot of cases where we would think about something one way, like a certain time discount in some way, and they would think about it in a different way. And we would realize that after everything is built, so you have to go back and like fix everything, which is not necessary. So make sure you're aligned in scope and goals in the beginning before you do anything would be a key tip, I think.
You.
So that's So yeah, it's like a long-winded way of saying like communication is pretty important.
Thank you.
Awesome. Let's wrap things up there with a huge thank you to our guest, Emily. Thank you so much for spending your time and sharing your experiences, your career journey, your all these projects and insights with us. We really appreciate it. For folks who are here who are not in our MS Data Science program, I'm just going to share a link in the chat for a new community newsletter we're starting up that will help folks stay in touch with events like this one going forward into the future. So you'd be welcome to add yourself to that list to make sure you don't miss any of our upcoming talks. Uh, Thank you once again to Emily for your time this evening. We really appreciate it. And thank you for all of you folks joining us and for the great questions you asked. It's been a lovely night.
Yeah, thank you so much for having me. It's been a great day.
Awesome.